This is one of the more important sections we're going to cover. This starts our progress of using scan data to measure fuel injection operating conditions. Right now, we're going to use scan data to measure the fuel injection pressure from the oil. This will take some math skills because its hydraulic pressure intensifier gives us our 7.1 multiplication. But the scan data are going to be used for high pressure oil regulator values. Let's have a look at it. Here we're looking at a sample we picked up. We've got highlighted. The top line says injector control pressure. That's our oil pressure. It's 1,257 psi. The desired oil pressure just beneath it is what the command that the PCM is using to drive the oil pressure regulator. It wants 1,409. We're significantly lower. Let's see what this means by the numbers. 1,257 rounds out to be 8,929 psi. Sounds pretty good. That's what we're getting. But the computer asked for 14.9 multiplied by the 4.7, 10,007 pounds of pressure. So right off the bat, you see we're over 1,000 pounds below our target oil pressure, our injection pressure. Oil pressure relates directly to fuel pressure. But remember, the fuel pressure changes by a factor of 7. So 100 or so psi on the oil pressure turns into quite a bit more when we get to the output side. Now the other thing we've got to look at, there's more clues here. This says we're not getting the pressure we asked for. The question becomes, why? What's wrong? Well, let's look at one more thing. We're going to take a look at the pressure regulator duty cycle. It goes from 0 to 100%. Right now, we're at 52%. That's really kind of a high number. This number will get higher to raise pressure higher. So we've used over half of our available duty cycle just to get 1,200 psi. That's pretty low. On a normal situation, the pressure regulator went to 52 to get only 1,250. During normal operation, we'd have much higher oil pressure at 52% duty cycle. Let's look at another set of data, for instance. Here is an example. We want 3,452 psi. We're getting 3414. That's close enough. But we're only at 71.5% duty cycle. We've got only a 25% higher duty cycle than we had before, and now we're in 3,000 pounds of fuel pressure. See the problem? We should normally see values this high only when we have very high oil pressure. When you go over 50%, you should have significantly higher than normal oil pressure. You should be accelerating. You should have a high fuel demand. There should be a reason. Now, what reason would we have for the duty cycle to be too high? Well, possibility, oil leaks, the high pressure oil pump. We'll talk more about that when we get there. We're going to talk more about using scan data. But this is the fundamental thing we're trying to teach here. Use scan data to evaluate it. We're going to try to use this information, and when we get to the high pressure oil pump, we're going to use this information again, and we're going to talk about finding oil leaks and so forth. And there's going to be other clues we look at besides just this one. So let's go on and go back and look and get the rest of the details on our fuel injectors.